Number 1 says, you are given a clear aqueous solution containing potassium nitrate. How would you determine experimentally if the solution is unsaturated, saturated, or supersaturated? If something is unsaturated, that means that you can add more of the solute and it will still dissolve. If a solution is saturated, that means you can't add any more solute to the solution without it dissolving. If a solution is supersaturated, that means it already holds more than the maximum amount of solute. The way you would make a supersaturated solution is by heating it, adding more solute, and then letting it cool. Aqueous silver nitrate reacts with aqueous potassium iodide to form a precipitate. Write and balance the equation. AgNO3, which is aqueous, meaning dissolved in water, added to potassium iodide, also aqueous, meaning dissolved in water, yields potassium nitrate and silver iodide. What type of chemical reaction is this? We know that it's a double replacement reaction because there are 2 compounds on the first side and 2 compounds on the second side. Only one of the products can be a precipitate. The way that we figure this out is by using the solubility rules. Look for these on one of your worksheets, like this one. So let's look at potassium nitrate. One of the solubility rules says, all nitrates, chlorates, perchlorates, and acetate salts are soluble. That means potassium nitrate is soluble. If it's soluble, it can't be a precipitate. What about silver iodide? One of the rules says, all chlorides, bromides, and iodides are soluble with the exception of silver, lead, and mercury halides. So, iodide is soluble, except silver, lead, and mercury. So this iodide is paired with silver. That means silver iodide is not soluble. If one of the products is insoluble, meaning it can't dissolve in water, that product is the precipitate. Let's talk about types of reactions. In a single replacement reaction, you will see a single element plus a compound yields a compound plus a single element. But you'll see the single element from the beginning switch places with one of the elements in the compound. See how that works? I'll give you an example. Here we have magnesium plus hydrogen sulfate yields magnesium sulfate plus hydrogen. What happened here is that the magnesium switched places with the hydrogen. In a synthesis reaction, you're going to see 2 elements or 2 polyatomic ions combine to form one compound. Here's an example. 3HF plus 2N2 yields HF3N4. You've got element plus element yields one compound. In a synthesis reaction, you're looking for one product. In a decomposition reaction, you're looking for something to break down into smaller parts. So you'll have a compound yields an element plus an element or a polyatomic ion plus an element. Here's an example. Iron oxide, a compound, yields iron plus oxygen, 2 separate elements. In a double replacement reaction, you'll start with 2 compounds and yield 2 compounds. But what happens is the first elements or polyatomic ions in these compounds switch places. Again, anytime you have a replacement reaction, you're looking for things to switch places. Here's an example. iron nitrate plus sodium iodide yields lead nitrate plus sodium iodide yields lead iodide plus sodium nitrate. In this reaction, the lead and the sodium switched places. Let's talk about redox reactions, or oxidation-reduction reactions. Silver tarnishes when it reacts with hydrogen sulfide in air. So we have solid silver plus gas hydrogen sulfide yields solid silver sulfide plus hydrogen. The silver is the substance that's oxidized. The substance that's oxidized in this reaction is the silver. We know that because it loses electrons. It starts out with a charge of 0 and ends up with a charge of positive 1. The substance that is reduced in this reaction is the hydrogen. We know this because it gained electrons. It started out with a charge of -1 and ended up with a charge of 0.